Assalamu alaikum, dear students. Let's start with the first experiment of the electrical testing 2. The first experiment of the logic circuit part is about the logic gates here. Okay. In this experiment, we have to do two things. First of all, we are going to study about the equipment which we are going to use for our logic circuit experiments here. The second thing is we are going to study about the working of the basic logic gates here, and most probably we will be drawing, or we are going to fill the truth tables of all these gates here. Before starting with the experiment, let us discuss our master unit which we will be using for all our experiments here. So this is known as the Digital Logic Lab, and the model number is KL31001, and all the inputs and output which we need for our circuit, we are going to get it from this master unit here. So there are many things on this master unit. I'm going to use, or I'm going to explain only the things which we are going to use in our experiment here. So first of all, what we have, if you see here, this is the DC power supply here, and we are going to use the fixed power supply here. So all the modules which we are going to plug in here. So all the modules which we are going to work with need some power supply to operate here. So we are going to use the power supply from here to connect it to the all the modules, whatever module we are using here. Okay, so just remember one thing, for all our experiments we will be only using the plus 5 volt and some of the grounds here. Okay, we are not going to use the remaining three here. So remember, if it is given to you in the procedure, or if it is not given to you in the procedure, whenever you connect a module here, you need to give it plus 5, and we need to come and connect the ground here with the ground here. Okay, next thing which we are going to use is the data input switches here. So basically we have a circuit here. Whatever circuit we connect, we need to test it by giving some input here. So in case of logic circuit, the input can be either 0 or it will be only 1 here. So we have only two values, 0 or 1, because we are talking about the binary values here. So what we have here, so first of all, we have a data switches here. We again have two parts here. For the first experiment, we are going to focus on the first part only here. Okay, so again remember, for all our experiment we will be using the TTL levels here. We are not going to use the CMOS. So please, whenever you make a connection, don't connect it in the CMOS, only connect it in the TTL here. Second thing here, we have four switches here. So switch 0, 1, 2 and 3 here. Okay, so what we have, whenever, like you can see, one switch is down, the remaining are up here. So if it is down like this, so it means I am giving logic 0 here. If it is up like this, it means I am giving logic 1 here. So depending upon whichever input I am using, if I need to use 1 and if I need to give input 1, I will make it up. If I need to make it 0, I will keep it down here. Okay, this is again the same thing here. This is the DIP switch 1 here. Okay, so what we have here, I have 7 points from 0 to 7 for DIP1. So you can see here, this one is DIP1 here. Okay, again, it means this is 0 corresponding to this 0, because this is bit 0. Okay, it will be written 8 here. Okay, but don't confuse with it. This is bit 0 as written here. So it means the first one is the first one. The second one will be here, 2 will be here, and so on. So you are going to have the input in 8 inputs from here. Similarly, if you want to use DIP switch 2, you can connect it with the second one, again using the same thing. 0 will be here, then the next one will be 1, 2, 3, 4 like this. Okay, again the same thing here. If you see here, if the switch here is down, we say that we are giving the input 0. If it is up, we are giving the input 1 here. Next thing is about the pulse switches here. The pulse switches we will be using whenever we are working with the flip-flops, and I think the shift registers also. Okay, so whenever we have the sequential logic circuit, we are going to use the pulse switches here. Again, simple. When you click one time, it means you are giving one clock pulse here. If you need a positive pulse, you will use A here. If you need a negative pulse, you will put it as a complement here. Again, we are going to use only the TTL levels here. We are not going to use the CMOS here. Okay, next one is here the clock generator here, which we will be using in the last two experiment, or the last experiment about the counter here. Okay, so what we have, since we are talking about the binary value, the logic circuits here, so it means we are going to have only the square waveform here. So simple. We can adjust the frequency of the square waveform from here, and we can use a TTL here, meaning this will be your positive, this will be the ground level here. Again, if you see here, for example, if I give the 100 ohm frequency here, the range, so it means from minimum to the 100 ohm. If it is 1 kilo, then I can rotate this knob, means from 0 or from the minimum to the 1 kilo and so on. So depending upon whatever range you have, you can adjust the frequency from here. Obviously, whenever we will be using this one, we are going to first measure the value of the frequency here using the oscilloscope. Okay, so whenever we do the counter experiment, we will be using the oscilloscope along with this the clock generators here. Okay, next thing is, for all our inputs, obviously we need to get the output here. Okay, we need to measure it. So how we are going to measure the output? Simply by using the logic indicators here. So we have like 16 points here, so we can measure 16 output directly here. Simple logic circuit. It means if the output is 0, the LED will be off. If the output is 1, the LED will be on. Simple. Okay, so in the manual we have basically used, like for example, connect this particular input with switch 0, this one with switch 1, connect the output with L1 or L0. Okay, so this is only the reference. If you connect like this, perfect, no problem here. But if for example we say that connect the output with L0, and instead of L0 you connect it in L8, perfectly all right, no problem with it. The only thing is, whenever you are looking for the output, check the output LED L8 here. Okay, so this was something about the master unit here. Now on the master unit, if you rotate it, okay, on this time on the back side here, on the back side, what you will have, you will see this switch here. Okay, so from here we can off and on the master unit here. So for example, if I'm making a circuit, or if I'm making changing some circuit, so the good practice is, whenever you are changing something, off it. When you finish the connection and you want to run it, then you can make it on, you can make it up, it will start. Okay, so whenever it is on, this LED will be glowing. Okay, whenever it is on, so you can understand. Secondly, this is on the working bench. Okay, what we have, like all these cables are connected here. So if we want to run an experiment, first of all we need to switch on this working bench here. Okay, by making the breaker up, and when you finish every experiment of this one, and also of the bench here. Okay, by making it down here. Now let's start with the first experiment. In the first experiment, if you see, like in the manual, what we have provided you with the diagram here along with the steps here. Okay, so for example, first of all, when you open the manual, like for example, the first experiment is gate characteristic measurement here. So what we have here, basically, if you see here, we have a diagram here. Okay, now what you can find from here, first of all, if you see here, the download, we have KL33001. It means this is basically the module we are going to work with, and this is the block D, means in the module KL33001 we are going to work only in the block D here. Okay, so what we will do, we are going to put a module here in this space here. Okay, provided here. So now let me give you the example of the module. Okay, for example, okay, what we have, for example, this is the module KL33001 here. So please just take this module from the rack. Okay, when you open this block, this box, you will find a module like this here. Okay, in the module, again you can verify, like, okay, are these two same, this value and this value, because sometimes when the students use multiple modules together, they forget to put it in the proper box here. Okay, so they just put it in the box and just keep it here. Inshallah, you will not find any such thing here, because we cross-checked also. But still, if you find it, please change it. Okay, so let's suppose this is our required module here, and now in the module, what we have, first of all, this is block A, block B, block C, block D, and so on. So for our experiment, this is block D, so we will be working in this part only here. Secondly, if you see here, for all the experiment we have the input for different types of the voltages here. Okay, so maybe different experiment work on different voltages here. In our case, we will be only working with the +5 and the common ground here. Okay, so don't put or give any input to the remaining one. Only connect +5 with the +5 and ground or common with the ground here. Okay, so how to connect them? Simply in our lab, we are provided with the two things here. These are the cables and these are some sort of jumpers here. Okay, even for this jumper, you can also use a cable here. Okay, like for example, if I want to connect these 2 points, I can use a jumper here. If I want to connect A1 with, for example, C4, so just connect this one with C4 here using a cable here. Okay, so just giving you the hint. So this is our module which we will be working with. So now using the same module, like you can see here, first of all, what we did here, the first step, okay, before connecting any other thing, you need to connect +5 with +5 and ground with the ground here. This is the first step always. This, and again, keeping this one off, okay. Next thing here is, according to what we have, he said that we need to connect connection clips in the module. So we need to connect these connection clips here. So you can see B1 is connected with F1. I have put a jumper here. F2 is connected with B2. We put a jumper here. Okay. Next thing is for AND gate. First of all, we need to connect A1 and A2 to the data switch SW0, SW1. So this is your A1. This A1 is connected to SW0, obviously TTL level, and A2 is connected to the second data level here. Okay, switch 0 here, switch 1 here. Then we connect F3 to the L0 here. Okay, so this is all our connection which is given to you here. Now then he said that follow the input. Okay, so what we have, we are provided a table like this here. So for the AND gate, we need to fill the values here by executing the inputs here. So for input of AND, we have A1 and A2 here. Okay, so first of all, what we have, when we make A1 and A2 equal to 0, means my switches are down here, 0, 0. What is the output? The LED is off, so it will be 0, so it means this will become 0 here. Now, when I make A2 equal to 1, so which one is your A2 basically? If you see here, the first one was A1 here. This is your A2. Okay, so basically what we have, this A2 is connected here. So we make A2 equal to 1. The first one is A1, which is 0. So the output will be 0 because I have off here. Next time we make A1 equal to 1, A2 equal to 0. So A1 equal to 1, A2 0. The output is still 0. And the last one, when we make both of them 1, 1, what happened? The output become 1. So we just put it 1. Okay. So you fill this table here. Similarly, we will make the connection for the OR. For OR gate, what we have, connect A3 and A4 in these two switches here as given to you, and output F4 we connected in the logic indicator here. Okay, and the clips obviously we have the same here. Now again, what we will do, we will change the value of A3 and A4 here. So obviously A3 is connected here and this is A4. So first 0, 0, output is 0. When we make A3 equal to this is A3. When we make A3 equal to 0 and A4 equal to 1, what happened? It become 1, then the other way, and the last one. So you can see for the OR gate, the first value is 0, the remaining one is 1, 1, 1 here. Okay. Similarly, now for the NOT gate, if you see here, we are going to consider on this part here. So this is your NOT gate here. You know the symbol of NOT. So you can give one input here and you can take the output from here. So we connected the input here and the output here. So for NOT gate here. Okay. So when the input here is 0, the output is 1. When the input here is 1, the output is 0. So this is your NOT gate here. Okay. So obviously we are talking about basically C1 here. Let me show you here. C1 here, this C1 here. So it means we are only considering this one. So when the input is 0, the output will be 1 here, 1, 1 here. When the input is 1, output will be 0, 0 here. Okay. Next one is the NAND gate here. So for the NAND gate, what we have, we need to locate here. If you see here, this is the symbol of the NAND gate here. So simple. Even this one is also working, but I think better to use the first one because second one normally don't give the proper answer. So use the first one. What we will do, we will connect to inputs here and we are going to connect the output here. We will change the values here and we will record the output here. Okay, so just you can see 0001 or all the combinations are given here and the values are given. So record or fill for the NAND gate here. Similarly, NOR gate, this is the symbol of the NOR gate here. We give the input here, we give the output here, we change the values combination here, and we fill accordingly the columns here. And the last one is one when we have 00 here. Sorry, the last one is XOR here. So this is your XOR gate here. Again, we connect in the switches here. We are going to change the switches here and either giving 0 or 1 or whatever combination, like all the combinations are tried here. Just fill the table accordingly. Okay. So this was your experiment 1, first part of the experiment 1 for about the logic gates here. Thank you so much. Assalamu alaikum.